This is Mr. Anderson for Akella Community College, and we're going to be looking today in this first part of a multi-part series about logarithms. We're going to look at converting logarithms, and we're going to have some special logarithms to look at as well. So from the previous video, we kind of introduced what the logarithms, how they're kind of equivalent to these exponentials. We would look at this problem. We'd first of all have to identify its base. And its base in this case is going to be the 4. So that 4 is the base. The exponent is going to be called in this video the stage, or what stage we are at in our exponential. So we're at the second stage, because 4 to the 0 power is 1, 4 to the first power at the first stage is 4, and 4 to the second power is 16, and this is the result. And I'm going to convert this to a logarithm, and I'm going to convert it by starting off with my base b, so my base is 4. The result is 16, and my stage is 2. The nice thing about the logarithm form is that the stage or exponent is now all by itself. I mean, you could think about how do I get the 2 by itself. You can't divide by 4. You can't take, you can't just move the 4 to the other side. So what we have to do is convert it into the logarithm form. So using abstract numbers here, we'd start with my base q, our result p, and set that equal to my stage x. In this situation, my base is 2, my result is 1 over 32, and my power here is going to be negative 5. And if you're curious about how that happened, the negative, just as a little reminder about exponents, the negative exponent would flip this on its head, so it would be 1 over 2 to the 5th power, and 2 to the 5th power is 32. So these are equivalent. I just wanted to show you that because we're going to be looking later on in a section with negative exponents. That's going to be kind of important. Now over here, what do we put down near the corner? We put the base y. Our result is x, and our power or stage is going to be t. In this next part, we are going to be looking at the logarithm equation, and I'm going to start with this and then go to the exponential form. So here my base is 3, my power or stage is going to be 0, and the result is 1, which actually shows that anything to the 0 power is 1. Now here you're looking for the base, and this is a special kind of log. This is called the natural log, and the natural log is written as ln, kind of like natural log backwards, or log natural. So ln and l, it's a good way to put it in the memory, but one thing about that is the natural log is the same thing as writing log base e, and we'll be learning more about base e in a future video, but I want to show you that this problem can be written as log base e of x equals y. So if I was to write this as an exponential form, my base is e, my power is going to be y, and my result is x. Down here, my base is 5, my power is x, and my result is 25. And now it says do not solve, so I don't have to show that that's a 2. Here, my base is x, my power is 1/2, and my answer is 9. And this is another reminder, since we're kind of like looking at older options, the x to the 1/2 power, that's the same thing as square root of x is equal to 9. So the answer to this problem would be 81 for x if I had to solve for it. So for our final part of this video is we're going to use some evaluations. Now you will need a graphing calculator for the last problem on this worksheet here. So what we're going to have here is evaluate log base 10 to the 10. Now what this means is like I'm asking for like what stage would I raise the base 10 to get to 10, and the answer is 1. The answer in this problem is 1, and a way to look at that would be if I'm at base 10 to x is going to be equal to 10, well that's going to be 1. And looking at the problem next to it, if I'm at base 10 and I want to get to 100, what power do I need to use? And I wrote the answer without actually just thinking about that. So the power I would need here is 2, because 10 to the second power gives you 100, or the result. So 3 to the what power gives you 9, because again we don't know what this is, and the answer here, x is equal to 2. So since we don't know what this is here, so it's some 9 to the what power will give you 1, and the answer there is going to be 0. 9 to the 0 power is equal to 1, so the answer to this problem is 0. Okay, so we're in base 5. Our result is 125, so 5 to the what power is equal to 125. The answer here is 3. But things are a little bit trickier when we have this. This is another very special logarithm. You'll notice that there's no base written, but this is called common log. And common log is because it's in base 10. And we actually are in base 10. We kind of think of ourselves in base 10, 0 through 9, 10, then back again. So we're trying to go and log a base 10 to get to this. And this is the one I'm going to have you use your calculator to solve. So by putting your calculator right here on the screen, you'll notice you do have a log button. And if I click log and go inside of those parentheses with 3 zeros and a 1, or 3 zeros and a 1, or this would be 1/10,000th, this would give me an answer of -4. Or to basically freeze frame it here, so if I'm in base, whoops, gotta get my pen on. If I'm in base 10, I want to try to get to 0.0001 or 1/10,000th. So I'd have to move the decimal 4 spaces to, or actually lower than 0, or 4 spaces to the left if I was moving this from 1.0. So my answer here is -4. If this all sounds like my answer for x, if this all sounds like exponential notation, then yeah, you're right. We actually have looked at exponential notation for really big and really small numbers, and it's all about moving the decimal. So this log, if there's no base given, it's 10. Now, what's cool is that later on in videos I will be showing you how to find answers when the answer isn't so obvious. Like, let's say I had log base 10, again, which is a little redundant because, just writing log as base 10. But I want to get to like 57. Now, 10 to the first power is 10, and 10 to the second power is 100. So 10 to the what power is 57? Well, we're going to actually use the change of base formula in a later video to figure that out. But so far, I hope you found this information helpful in going back and forth from logarithms to exponential functions, and back again. Thank you for watching.